Good morning, good afternoon, good evening. We gotta say you're welcome. We're gonna present an article about the stoichiometry and the kinetics of PHB producing methanotrophs. The authors are Cristian, Alejandro, Siachoque, González, our partner Diego Alejandro Ochoa, Cristancho, and me, Juan José Vásquez Gallo. Okay, as well, in this study, the modeling is used to describe how oxygen and the nitrogen source affect the stoichiometry and kinetics growth of the PHB production in the type 2 of methanotrophs, the Methylosinus, trichosporium, OB3B, and the Methylocystis, parvus, OBBP. Significant difference were observed with the major implication for the use of these species in the biotechnology applications. The methanotroph, a subset of methylotrophs, obtain both the carbon and the energy for methane and constitute the major terrestrial sink for the methane. In the industrial application, the methanotrophy is of interest of a single cell protein production, the production of the polyhydroxybutyrate (PHB), especially for chemicals, and the bioremediation of the true co-metabolism. Under the nutrient limit condition, the different methanotrophs have evolved and different strategies for growth and survival, optimizing the growth of the type 2 and their capacity of the production of the PHB, the application of commercial and environment interested. So, in this study, the effect of oxygen and nitrogen source as the kinetics of growth of the PHB. As well, in this presentation, we will see a plastic alternative for like a PHB, the oxygen reduction equivalence, the nitrogen fixation, and the oxygen sensibility.
Methanotrophs, natural consumer of methane. Methanotroph, a subject of methylotrophs, obtain carbon and energy from methane. Octane has a marrow characteristic of these gas. They are of interesting for single cell protein production, PHB production, especially chemical and bioreactors from cometalons. Type 2 metallotrophs create intracellular PHB granulars under neutron depleted and nutrient limited conditions. These granulars act as reducing equivalence reservoirs, allowing for rapid growth when nutrients repair. Methane consumptions. Methane is their primary source of carbon and energy. PHB production. They produce PHB when nutrients are limited. Bioremediants, they are used for bioremediations down cometalons. Next. PHB and biodegradable alternative to plastic. PHB of industrial interest here has biodegradable substitute for fossil carbon-based plastic with physical properties similar to propylene, using biogas from wastewater, detergent plants, and landfills as feedstock can reduce cost and improve energy outcomes. Potential for increased carbon capture -2 kilograms CO2 equivalents feeds for kilograms methane comparable to 0.1 kilograms CO2 equivalents fights for kilogram corn delivered sugar. Biodegradable PHB after an environmental creating alternative to traditional plastic, custom reduction using biogas has feedstock can reduce production cost and life cycle 17 indicates a more favorable energy account, 37 megajoules for kilograms PHB from biogas compared to 42 megajoules for kilograms PHB from cultivated sugar. Next. Oxygen and reduction equivalents are essential for methane metabolism, starting with oxidation by monoxogenesis. Nitrogen metabolism as affected is demand. Type 2 methanotrophs using glutamine synthase and glutamine synthase. Ammonium is oxidized to hydroxylene by methane monoxygenase, which increasing the demand for oxygen and reducing equivalents. The picture shows the methanol oxidation pathway type 2 methanotroph of the effect of ammonium co-oxidation on this metabolism. A. Use of ammonium for cellular synthesis. Their ammonium is assimilated by the Sinsar cycle for biomass synthesis. In this scenario, metabolism is not negative. Factor has ammonium is used and nitrogen. So cause when interacting with CH4 oxidations. B. Competition between methane and ammonium for the immuno enzyme. Ammonium can be oxidized by methane monoxygenase immuno, which creates competition between HCH4 and for the enzyme has and resultant the conversion of methanol is reduced. C. Inhibition by ammonium co-oxidation production. The oxidation of NH4 minus produces hydroxylene and nitritro, which can be toxic to the soil. Next. Nitrogen fixation and oxygen sensitivity into fixation was done to the limited to type 2 Methylotroph modes, nitrophiles, metallitolocides, metallitolocinaus, and metallotosulfides. Nitrogen minor to type metallotroph groups and O2 um, the 4 to 10% and preserve MO oxygen sensitive. Nitrogen is affected by O2, which varies by spice, and optimal ground only low O2 0.05 to 0.55 bars favors in two fixed quality or too sensitive is case of the optimism growth. X.
Okay, as well, we gotta talk just a little bit about experimental setup and grow monitoring, because in special we need to be focused on the experimental results. Okay, as my friends say, the M trichosporium or OB3B and the M parvus or OBBP were grown under 6 different oxygen partial pressure in serum bottles using nitrate, ammonium, or nitrogen gas as nitrogen sources. Gas consumption and production were involved by sampling bottle headspace. Cell growth was measured via optical density, cultures in exponential growth were same for PHP production. After the methane depletion induced by incubation with a concentration of 1 to 1 of methane and oxygen without nitrogen, For both strange 18 incubation condition, we have like 6 level of oxygen molecular and 3 nitrogen sources, and were evaluated for the growth. The battle headspace was sampled periodically to evaluate methane consumption, oxygen consumption, neutron consumption, and the carbon dioxide production.
Now, in this page, I say about boiling of kinetic. In this first equation, we can see mm, describe it as a batch system with controlled volume. And this equation is the mass rate of substrate methane accumulation, where Cg is concentration in the gas phase, Bg is the volume of the gas, Cl is the concentration of the liquid phase, and Bl is volume of the liquid. The second equation is a mu, where mu is the specific growth rate due to synthesis, is the concentration of the rate limit substrate, mu max is the maximum specific growth rate, and Q is the concentration of the gas on half the maximum rate. The last equation is maximum specific rate of the substrate utilization. Next. Now in this page, the first equation is mass rate of biomass accumulation, but this equation is accordingly is very more big than a q to q, and zero order kinetics apply, and the mass rate of biomass accumulation is this equation. The second equation is accumulation and the mass rate of biomass. In this equation, multiply the above equation by g sub x on about sides. The effect that the gas phase term HCBG as on mu max become evident, where X represent the mass of the biomass. Next. Now we can see a stoichiometry of study by page producing Methanotrophs. In this study, during cell synthesis, a fraction of the electrons in three in three equations. In first equation have a cell growth by recurse nitrate. Second equation is ammonium with resource nitrogen, and last equation growth phase is recurse nitrogen gas. But for production BPH phase and no nitrogen as resource nitrogen, and have a change in the biomass because growth phase biomass is different. Grade phase the biomass in the production BPH. Next. The results, this study, we can see the strain OB3B is values of phi E and phi S is very more big as our BOBP, but in next figure we can see next we can see the figure, two graphs how in the same partial oxygen pressure that 3 atmosphere, the microorganisms shown on the right OBBP produces more biomass in less time than the one of the left. The productivity is calculated and the difference in percentage is significant. So 16 grams BS is volatile suspended solid mass in 22 hours compared to 88.5 hours. Next.
Okay, taking in mind the results about experiment, we have the conclusion of the application for the article are and our own conclusions. Okay, for first time, the optimizing growth of the type 2 Methanotrophs and their capacity for PHB production is of the commercial and environmental interested. In this study, the modeling is used to describe how the oxygen and the nitrogen source affect the stoichiometry and the kinetics of growth and the PHB production in the type 2 methanotrophs, of course, but the methanotroph F trichosporium or the OB3B and the parvus the OBBP. And a key parameter is the methane required to produce a unit of PHB. These results are highly organism specific. Such analysis can be informed bioreactor design and could be scale-up models and, of course, a life cycle of the assessments, like the LCAs is an acronym. And for our own conclusion, we have that is shown that the type 2 methanotroph require an strict control of oxygen partial pressure to ensure the adequate pH production, like we saw at the graphics and in the tables. And for be more specific, we have that the study demonstrated that the Methylosinus trichosporium, the or B3B, produce a higher yield. A yield is the prom of the of the production per hour of the PHB. Like we can see, we have a 1.13 grams of PHB per gram of methane compared to the Methylocystis parvus, the OBBP, that we have a 0.88 gram of PHB per gram of methane under the optimal conditions. The stoichiometry model indicates that the strain OB3B has a higher fraction of the electrons used for cell synthesis, like a 0.95 than strain that the OBBP that has a 0.74, and the result highlight the importance of the nitrogen source and the oxygen levels of raw kinetics and the PHB production, informing the future bioreactor designs. As well, we have all these conclusions taking in mind the graphics and the tables that the article has. As well, we want to say thanks for watching and yes.
Thanks your attention.